Humans of Earth, welcome to Will AI Snap That. My name is Michael Rollins, and I am joined as always by my co-host, Thanos, he of the Snapdom. We are here today to help you understand your future joblessness and what you should do in order to curry favor with our robotic overlords. Thanos, how are you doing, my friend? Are you still in Greece?
I'm still in Greece. The last 2 days in the kiting location.
Man.
So I'm gonna be sad next
So
week.
let me, hold on, I want to you're in Greece all summer, kiting for a significant portion of it, but next week you're going on vacation.
That is correct.
Like you roll deep. You roll
The
real
kiting
deep.
is more of a workation. It's kiting during the day and then get a bunch of work done in the evening
Yeah.
when it's dark outside and you
Yeah.
can't really go kiting.
Yeah, you're
Although
arbitraging the time zone is what you're doing.
evening kiting, now that's a thought.
I,
Moving that aside, I do
yeah.
get work done while in kiting for those weeks, but next week I'm just gonna be off.
Excellent. Excellent. Any particular plans? Are you visiting Olympus? Even where is Olympus?
Exploring Amsterdam.
Oh, I have heard you need to be careful where the red lights are.
We're taking the kids, so I don't think we'll be hanging out near the red lights.
And the kids should be careful where the red lights are.
I
Actually,
think there's probably a lot more to Amsterdam than the red lights, but
oh, I have
I
a
heard
funny.
there's some famous artist museum.
I have a funny story about Amsterdam. So when my
Is this
wife and I,
episode going to be like PG-13?
yeah, it's fine, it's fine. My wife and I, shortly after we got married, her brother was stationed in Bamberg, Germany, and so we got married in August of 2000, and so sometime in May, I think, no, it would have been in the winter, so it's probably like February of 2001. We flew out to visit her brother in Bamberg, Germany, and then eventually drove all over Europe. Is literally, I have so many memories from that, and a lot of them are good. We got lost. We couldn't get out of Zurich. We got lost in Zurich for 5 hours. And every time we tried to leave, we ended up back in Zurich. Keep in mind, this was before GPS, right? We had printed out MapQuest directions that
Well, at
ended
least it
in
was MapQuest.
Zurich. We did not
At least you
have,
didn't have like the big atlas.
yeah, dude. Man, the children of today, these late millennials have no idea what life used to be like, and Gen Z and whatever comes after that. Okay, so my wife and I,
My kids would say, "Dad, it's going to be one of those when you were a kid stories."
yeah, now get off my lawn. So we were on our way there, and we had been traveling, I don't remember why, but it took us forever to get to Germany. And so we stopped over in Amsterdam, and we were walking around. We were we couldn't, our eyes were crossed. We were so tired. We're walking around Amsterdam, or the Amsterdam airport, and we're looking at all these beautiful pictures of Holland. And I finally looked at my wife and I said, "We should really go to Holland one day." And she goes, "Yeah." And said, "I wonder how
Nice.
far it is from here."
Yeah.
I mean, I'm
Nicely
normally
done, sir.
I'm not gonna call myself the sharpest bowling ball in the shed, right? But boy, that was a moment. We finally and it wasn't until a
Someone
few
had to explain that one to you, or
no, it wasn't
you
until
figure
a
it
few
out.
days later that I just went and I looked at my wife. I was like, "You were in Holland." It was amazing. It was truly amazing.
Yeah.
Okay, so
Should also check out a nearby place over there called the Netherlands. It's
yeah,
really
I've
nice.
heard. I've heard that's a
Yeah.
lovely spot. Anyways, it was truly it was pretty funny. So, okay, today, what are we going to talk about, Thanos?
I think we should see what happens when you have more than one things that are called AI, and what happens when you put them together.
Yes. So we have talked in the past about this expert agent stuff that I'm working on and still working on it. And boy, let me tell you, I have learned some truly interesting things about going from a single core LLM agent to a multi core LLM agent. And wow, it
So
is.
break this down for me here. When you say single core agent to multi-core agent, do you mean one agent but uses two underlying LLMs, or are we talking about multiple agents using multiple underlying LLMs?
Okay, so it's
What's the use
easier.
case? Let's walk us through it.
I'm going to use expert agent to talk about the whole thing, but what we're talking about is true of all agents in general. And you know what you end up finding out is that you've got agents built on agents, and it's agents all the way down. And so what 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 I've what we moved to recently is, you know, previously we had one single agent that, or one single LLM core. It was ChatGPT 4.0 mini or oh 04 mini. I don't remember which one. And it was responsible for everything, right? It's got a like 225,000 token context window. It had instructions on how to access all the different data sources. It had, you know, and it was generating the answers, right? And as part of the chat.
So when you say an agent, just to be clear here, you're talking about some kind of an LLM with some instructions and access to some tools
Yes.
that you can throw some text at and get some text back. That's the definition of one agent, or do we have like a thing with tools in a loop?
Okay. Well, that's the interesting part. When you move from single core LLM to multi agent as the core, you get rid of the loop. And the method that we chose actually based on something called the Blackboard model. So the Blackboard model works like this. And you know, as I sit here and tell you this, I have not actually verified that the Blackboard model exists. And I've wondered if this is a hallucination that our good friends at Gemini. I'm like, I need to go double check this. So, anyways, maybe I'm wrong. Maybe it's a
If it
hallucination.
existed, or if it exists,
Yeah. If
what does
it
it do?
didn't exist prior, it does actually exist now. So the idea is called the Blackboard model, and it was developed in the 80s. And it's this idea that if you're going to have a bunch of AIs working on something, how do you coordinate information delivery? How do they talk to each other? How do they know which one should be running at any one given time? Okay. And the Blackboard model more or less works like this. You've got this Blackboard that the coordinator AI manages. And the coordinator AI will look at what it's supposed to do, and then it will start tapping other AIs on the shoulder and saying, I need you to go do something for me. When
So
there's
the other AIs are essentially tools for the
For the
coordinator AI.
coordinator, yeah. And actually, the only thing the coordinator does is looks at the problem and then tells somebody else to fix it. That's all the coordinator agent does. And when the
Does it make up other entities? It's like, I'm going to ask God to do this. And be like, no, 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 no. You only have access to these models. You can't cheat.
it does in fact know what it has access to. And I mean, honestly,
But does it use it?
at this point, we probably could put a coordinator agent in place that could spin up a custom agent. Like this stuff gets weird real quick. And so the coordinator agent goes, I want you to work, I want you to work, I want you to work, right? And then when each AI is done, it goes to the Blackboard and it writes what it's done on the Blackboard. It writes the output.
And the coordinator AI presumably could decide we need a loop. So we need to have agents A, B, and C, like first A, then B, then C. And then I take all the results and ask them a new question. Or they could
Mhm,
say, I'll take it to A, take the results, feed it to B, take the results, feed it to C. It can figure out
mhm.
how to approach this. And presumably its instructions.
Yep. Yeah, the coordinator agent can look at the output of one existing of a different AI and say, "Oh, that's interesting. Okay, you guy over here, I want you to go look at this as well. I want you to take this output and I want you to go do your thing." And so what you end up with is you end up with a collection of specialized AIs. And so that's the approach I chose to take. I had a lot of assumptions going into it. I had a lot of assumptions. And it turned out that the majority of my assumptions were wrong. So let me describe the agent, the AIs that I have in place. This is so hard to talk about when you're building an agent, but that agent has agents in the middle of it, and then those agents could have agent like, oh my God. So, okay,
I see what you mean, agents all the way
agents
down.
all the way down. Like, and when I say that you probably could have a coordinator that spun up custom agents to do things, like I'm dead serious. That is well within the realm of possibilities. So as I was looking at the structure of the system, there's several different data sources, right? There is like a true structured SQL database. There is a RAG database, and then there's memory. And the memory actually is what's interesting is that initially I was like, okay, the memory's cool. I'm really not sure if it is as absolutely necessary as I had presumed. And what I'm realizing is that the memory may be the single most important part of this because it is the blackboard. And not only is it the blackboard, but because there's things like semantic memory where it memorizes facts, and because we have the potential for semi-structured data within the SQL database, meaning we don't have foreknowledge of what the user may want to work on. And the user can decide to import a data source that we don't actually know the structure of or know like what the data is even about. And so what's really interesting is you can use semantic knowledge to get around a bunch of that. Because if when the user is importing the data, you prompt the user, what's this data set about? Well, the user can then write down what the data set is about. You pop that into, including columns and things like that. Then you pop that into the semantic memory. And when the user data access agent begins working with the data, it can pull semantic memory to say, what's this about? Oh, okay, well, I can make sense of it now. We'll get to that in a minute. But memory becomes really important because it's got three tiers. You've got working memory, and that's the blackboard, right? You've got episodic, and that helps you coordinate between chat messages and even across chats. And then you,
And do all the agents have access to all the memory, or is
yes,
it only if they have to go through the coordinator agent to get access to the memory?
no, they all have access to the memory.
And is it compartmentalized, or can everyone read and write from all memory? Because that could get rather schizophrenic in a way.
So, like, explain that for me a little bit more.
Well, so for example, the role of the coordinator would be to perhaps by itself or through some other agent apply certain reasoning or certain sort of criteria before accepting the results of some other agent. So right, so some
Mhm.
agent returns some results, you vet them,
Mhm.
and then you write them into the right part of memory that you want to store those. But if all the agents think they know best, they might just go straight up and like overwrite something in memory without having it vetted first.
That's an interesting question, and it's honestly not something I put a lot of time into thinking about. The
Check it out tomorrow, and then we can talk again on
right,
2 days from now,
the
and
the
we
the
can make
gen-
sure we.
one now there I have at least put a question mark on this because do we should we have an agent responsible for memory is something I'm curious about, and maybe that responsible agent is the coordinator.
And maybe there's different memories, right? Where there's memories
Mhm.
in between agents for specific reasons. And yes, you can read and write into that memory that is shared between these X agents, but these Y agents
Yeah,
share this other memory, and only this agent has access to this memory. But
I have
again, I guess it
yeah
would depend on the kinds of problems you're trying to solve,
yeah.
but
I mean,
kind
one
of
thing what
interesting
I
to think about.
what I will tell you is that the memory itself is backed in a Postgres database. And so anytime you write something to the memory, it gets stored as a row effectively. Anytime you read from it, you're reading a row. As far as the actual agents are concerned, that they have no insight whatsoever into the actual implementation. But because it's backed by a Postgres database, because I can set that up, it does, in fact, it can be like you can sequester information off into a spot that nobody else can get access to it. So You could actually use the memory as like a message passing layer if you wanted to.
Yeah.
I honestly am not sure what the implications of that would be, but it's a curious, it's actually an interesting thought to really go through. Okay, so we have all these agents, right? We have the user data access agent, we have the RAG database access agent, we have the answering agent, maybe we have a memory agent, we have a coordinator agent, and then finally we have a critic agent. Okay. And each of these things has different capabilities. They have different tools that they can use, right? The RAG database agent just runs a RAG database query. That's all it does. The answering agent
Do
is
you always wrap those in an agent, or sometimes if the tool is simple enough, you just might call it like a tool?
I have wrapped them in agents because and this will be a lot clearer in just a sec. But each individual agent has its own LLM at the core, which means it has its own context window. And that's where things get really important. So here's what happened. I built this thing out and I said, I was working with our friend Claude Code. I went over to Gemini Pro. I told it what I wanted to do. I had a deep research conversation with it about it. I made all my selections. I had it generate a PRD. I took the PRD, moved it into a .md file, and then put the PRD into a place that Claude Code could access it. And that's what Claude and I worked on as we built this out. Most of the agents are just kind of tool using agents where you've got the core LLM, and then that core LLM has a few tools it can pull on. The user data access agent is a coding agent, and it is its own very special beast. It can write its own SQL. It can do its own thing. I've learned a lot about that in that process, but that may not be a conversation for today. It depends on time. So when I put all this together, I put it together based on, the Langgraph network graph pattern, right? So the idea with Langgraph is that the coordinator agent can and will add and subtract edges and nodes to the network, to the graph. And that's how the coordinator says go do work. It just adds a new node to the graph. That agent that is doing the work can potentially add other nodes as well. But eventually the whole system, it fans out, all the work gets done, and then it eventually goes back to a shared point. And that's pretty much what LangGraph is for, right? LangGraph does the graph. I mean, that's how I'm using it. LangGraph does the graph, the building out of the agent graph, and it also does the memory. LangMem in LangGraph is a beautiful product, like just beautiful. Because you tell it what you want to back it with, and I was like, I want to back it with Postgres, and then the first time that thing spun up, it literally built out every single table it needed, and it'll check
Nice.
to see if there's any schema changes that need. I mean, it's like, wow, this is awesome. Okay, so here's my first assumption going into this. I was dealing with 45-second to 1 minute answers with a single core agent. I expected it to get slower. It got faster.
Curious and curiouser.
And I was like, to the point where look, this is one of those ones where I had to fix a few import things. I had to like go through and structurally change some of the code that the robot had generated. But once I did that, I just hit go and it worked. And worked the first time basically. And I was like, oh shit, this thing's wildly broken. I just don't know it. Right? I mean, every time I've ever had a product, or it's like you write all your code and then you hit the compile or go button and then you test it and it works. I That is terrifying to me. I'm not that good. Like I'm just not that good. And
Yeah, that never happens.
I've had it happen a couple times. And I was
Yeah, a couple of
actually
times on like, a three-line thing, right? It's like, oh, okay, that's cute.
no, there was this one time I built something out with like, dude, I was using HBase and Hadoop and doing all this crazy like metric analysis. And the very first time I went to test it, it worked. And I spent 6 hours trying to uncover how it was broken, and it just worked. I was like, this makes me so anxious.
Maybe it's one of those things where it's complicated enough, then you
Yeah,
don't know whether it worked or not. You just
that
think it
was
looks like it worked. Okay, we're gonna roll with it.
that's what I assume all the time. So, anyways, so this thing worked the first time, and not only did it work the first time, but I was getting answers in 15 to 20 seconds. Like, not only was it faster, it was significantly faster. And I was like, this can't be right. So I am using Langsmith. And so I went and I like traced all of the reasoning paths and everything. And it was actually doing it. Like it wasn't making up, it wasn't hallucinating things. And I could see it actually accessing data. Like it was doing what it was supposed to do. And it was faster. And it really did not make sense to me until I put it into the frame of context window usage. And here's the thing: when a single agent is running, it has one context window in which to work. And you and I and everybody that works with AI on a regular basis knows that the fidelity and the ability of the robot gets diminishes over time as that context window fills. And it also gets slower. And I hadn't really thought about that before. But when I started looking at this, each of these agents, even though some were dependent on others, when they spun up, they had a fresh context window. They would go, they would do their things, it would be lightning fast, and then they could produce their answer. And by distributing the load and increasing the number of context windows, I think that's why it got faster. Because the entire,
And if you think about it, it sort of makes sense, right? Because
yeah.
each agent is sort of exploring its own little multidimensional space.
Mhm.
And when your context window gets bigger, you're not exploring, more, I don't know if it's more dimensions, but you're exploring like a bigger part of the space, and it becomes harder to narrow down the kind of like a chain of reasoning that gets you to the right spot in that
Right.
multidimensional space. Whereas when you have a different agent and each agent has its own little area to explore, it can do a better job in exploring just that, as long as you then kind of find a way to organize these where if everyone explores their own space and gets the right results, then we have a way of then, taking the space that is created by combining all these results and then exploring that space to get the final result that we want.
Right.
So that's fun.
And so like, I mean, I was shocked. The idea that taking a single agent thing, breaking it into a multiple agent thing, even if the pure dependencies of part A has to happen before part B, and that entire thing gets faster, is so counterintuitive. And maybe at scale this doesn't hold up. I don't know. Like it's
When you say faster, I'm assuming you're meaning faster in getting results,
yeah,
but probably also faster in consuming your dollars. So you can
both.
watch your bank
Oh,
account kind of grow.
100% both. Like you are not, no, that's a good point. Like I'm not reducing the number of calls. I am not reducing the number of tokens used. At best, I am matching, and I wouldn't be shocked if I am increasing the number of tokens used. So that's a good call right there. Like you're probably not making money savings, but and though that would be
If it gets you the result that you need, then that becomes a
yeah.
different kind of economics you have
I
to
mean,
worry
yeah,
about.
you and I both know that every single solution in computer science is a series of trade-offs. So it's like I remember it in one of my computer science classes. We started talking about making trade-offs between time and space, meaning, okay, if we don't have that much RAM, then we have to trade time for the RAM, right? But if we have infinite amounts of RAM, oftentimes we can do things faster. And so it was like time space versus state space complexity or something was what we were talking about.
There is a thing where you can replace computation with storage. I think that's a
Yeah.
basically pre-compute it and store it, and then you just do
Yeah.
lookups.
Yeah.
And you can do that for any number of inputs, outputs, and paths.
Yeah. It still doesn't get around NP complexity though, which sucks.
Yeah,
So,
I'm sure someone will solve that.
right. So, okay. So I'm like sitting here looking at this, and what was funny is like even the coding agent, which it's not I like the way I set up the coding agent right now is not ideal, and I can actually dig into that a little bit. But even like the coding agent would turn out these results, or the when I would ask it to access data, it would say, "Well, I don't have access to that data." And I say, "No, you actually do. Like these are the columns that you have access to, and these columns are this." And it was funny because I was using our podcast data to test this, right? And so I asked it, "Hey, can you tell me what our best day for plays was or for listens was?" And it has access to our Spotify data and it has access to our YouTube data. Come to find out, Spotify lists these as plays. They do not list it as listens. And YouTube, the corresponding metric is views. So when I finally, because it went is like, I don't have access to listens. So when I finally told it, no, 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 listens are either plays or views, next thing I know, this thing's returning a valid response to me. And so by giving more definition to the coding agent, I was able to make the coding agent better. There is a wrinkle with the coding agent because I have to support semi-structured data. And I don't know a better way to describe it than semi-structured. The user can bring whatever data they want. If they're going to put it into the user data, it must have some structure, right? But that doesn't mean that I know the structure in advance. And I exacerbated the problem by assuming that the first type of data that a user will import is going to be CSV. CSV data is notoriously ambiguous. And so I didn't have any kind of data description initially. It is further compounded. So now we've got this CSV that literally could be anything. And then part of the import process is it takes each individual row in the CSV, it breaks it into what is effectively a JSON B blob, right? And it drops that into the Postgres database. So the Postgres database is actually storing JSON B blobs. And so it's really hard to write good SQL to extract stuff from JSON B blobs. It was doing it, it was actually kind of managing it, but it wasn't good. So, an interesting finding is that even with coding agents, what I'm going to end up doing is wrapping the database in an MCP server. And the MCP server adds in tool definitions that inform the agent what it is doing and what it can do. And that has been a huge learning is that even MCP servers in the middle of all of your agent interactions will make the entire system interact easier because MCP servers are self-describing. They are tools that the agent can use, and they describe exactly what they can do. And so by fully describing what the MCP server is, the agent it removes ambiguity from the agent. And by removing ambiguity from the agent, you increase its efficiency. So this was another thing that surprised me.
That's super interesting. I'm gonna go back to one of the things you said about the coding agent.
Yeah.
Is code an intermediate output for this project, or is code like a final output for this project?
You're
Do you
right.
write it and then run it, or do you?
The coding agent writes SQL queries and runs them on the database.
Nice.
And
And how do you make sure it doesn't delete your production
it
database?
has read-only access, and it only has access to specific
Okay.
tables. No, that's that. No, believe me, I have had coding agents.
I might have read a thing or two recently about
I
that.
have had coding agents delete the damn database, right? Like I've experienced it in my own projects. I have learned my lesson, baby. I told you about way in the past, the first time I ever started working with coding agents, I never gave the damn thing any input. So it started building out an example in my database.
You're so adorably eager
I
sometimes.
know. Yeah. It's like, well,
It's
you
like,
didn't
what
tell me what
are
to
you
do,
doing?
so I'm just gonna go do this. And I was like, why the hell is this thing creating tables?
My instructions are to be helpful
Yeah.
to
Oh
humans.
yeah. Yeah, no. So the coding agent can actually, it's just writing SQL queries. Now, one of the things that's important though is that I'm gonna structure the MCP server in such a way that it can input regular SQL queries after like they've been vetted and whatnot. But um, the what's the word I'm looking for? One of the techniques I've decided on in order to help add structure in is number one, whenever the expert agent is going to work with a set of data that's stored in JSON blobs, I'm going to create temporary tables and effectively extract those JSON B blobs into the temporary table for the agent to use. The other thing is going back to the semantic memory. If when the user creates the data source, I have them describe the data source and then store that in the semantic memory and let the coding agent know you can find data descriptions in the semantic memory. I don't have to have a complex metadata management system because the LLM is just doing it. The LLM can understand it. The LLM can work with it. So, I mean, this has been like, this is number one, it's been a blast. Number two, it's been terrifying because it's like the stuff just works and I don't fully understand how it works sometimes. And, finally, it's so much of this is counterintuitive. Like, so much of it is counterintuitive. And I just find myself fully surprised constantly as I'm working with this. So,
What's a good counterintuitive example? I love those.
that adding multiple agents speeds it up,
That's a good one.
right? I did. Okay.
The counterintuitive fun is fun. I was writing about this the other day because where intuition says action A has result B, that's relatively straightforward for you to get around your head. But when you need to have something, action A create something C that you don't expect, then you need to like figure out in your head what is the mental model, what happens between these dots, and like how do you run an experiment to figure this out. So it's the fun solutions are the one that are not necessarily the easy cause and effect, but like
Yeah.
the hidden cause and effects are the ones that you don't quite understand.
Yeah. To that point, and we're not going to talk about this today, we're going to tease this for the future. How do you QA this stuff? Because you now have a non deterministic system with subjective output. And you know that the individual agents are notorious liars. How? Even though I have a critic agent, right? I have an adversarial critic agent, and it is designed to say no. But
So the other agent bribes him, and it's like now they're colluding to.
yes, like that can happen. Like literally, that is a concern, right? And even though I have lane graph for visibility, you don't QA by looking at individual runs. You QA at scale.
Yeah, so I wonder like if this scenario happens like one out of like 999 times or one out of 1,000
Yeah.
times, then do you put two critic agents and now it happens one out of 10 to the power of 6 times,
Right.
and they add a third one and now it's like, all three have to somehow, or is there systemic risk? Do you have like three different AIs, like you use like three different LLMs to be each of your critics? So if the same kind of bribing happens, it's unlikely that all three will systemically fail.
There is one of the ideas
Did you
I've
say we're not going to talk about QA though,
we're
are we?
not, but this actually is not about QA. When you're looking at a system like this and you realize that it is a product and you want people to pay to use it, right? Trust is one of the most important principles of any user system. The user has to trust that the system is doing what it says and that the system is truthful. Now, previously, it was bad data in, bad data out, right? And so to trust that the system is not lying was pretty straightforward, but we can't make that assumption anymore. And so with the critic, the a really bad outcome with a critic is that this thing just says no constantly. And once it says no, you're sending it back to the original set of agents and saying, redo your work. Well, now all of a sudden you have an agent that won't respond for 10 minutes, right? That's not good. What you can do though is if the critic says no, it sends it back. The system does its thing. It then sends it to the agent again, and the agent will, or the critic sends it to the critic. The critic will assess it. And instead of saying no, the critic will annotate the answer as suspect, right? And so there will very likely need to be some kind of indication to the user that the critic is saying, I'm not 100% certain on this. Be careful with it, right? Because, I mean, look, every time you launch Claude Code, every time you launch Claude, every time you ChatGPT, Gemini, they got this little fine print in the bottom that's gray and hard to read that says, LLMs can make mistakes. Be careful with the answers. And everybody ignores it. It's like a EULA, right? End user license agreement that you just click agree. So there are ways that you can.
Yeah, I don't know that you completely ignore it, right? Because I think the same way when you work with a human, you recognize their imperfections. So, yeah, I was writing this example of like when you work, say, with a junior engineer, you understand what their experience and expertise and limitations are, and you give them suitable things, and you vet their responses for suitable mistakes, and you coach them in suitable ways, right? So when you work with the AI models, all the good engineering practices we still have to go around there need to exist. You can't just wing it. So,
Well,
so in a sense, you're codifying some of your judgment in places that make it easy, where it's codifiable, so you don't have to do it yourself. But at the end of the day, it's the human in the loop in some way, shape, or form, and where you can get the confidence that you don't need human in the loop, you can codify it in some way that a critic agent does the work.
yeah.
Good for you.
I think there's a.
But that activity still needs doing, right? You can't just
Mhm.
eliminate the activity.
Yeah. I think that there's, so I'm actually not as much worried about it in the engineering context as I am the end user context. And, what's really interesting is that humans have a built in suspicion of other people, right? The circle of trust. Some people extend the circle of trust easily. Some people extend the circle of, like, never extend the circle of trust, right? And oftentimes, if you lie to me, you're not in the circle of trust anymore. But in general, humans are actually pretty good at sussing out a risky situation with another individual, right? It's like there's this alarm bell going off in your head going, this isn't right. When you sit down with a car salesman, a lot of times you should be suspicious, you know? But part of the issue culturally is we've been taught that computers are right. And that if the computer is right and the human is not, you trust the computer. And the computer doesn't have a face. The computer does not have body language. The computer does not have any of the things that we use as humans to be suspicious. And so, the ideal outcome for human society in general is for us to be as suspicious of agents as we are of humans. But that is,
Have you heard of conspiracy theories?
listen, I am not in any way, shape, or form going to say that humans are good at suspicion. I am saying that we have a mechanism for sussing out shit that stinks, right? Like whether or not choose to use it, that's a different story. But
Yeah, I was reading something a fairly long time ago about defining hypothesis and evolution.
uh-huh.
And it's basically the gist of it, as I remember it, was that we're actually not really good at that. We're good at like cause effect, um, but we're not really good at that cause did not have that effect, because that has to go through kind of a different pathway in figuring that out.
Mm-hmm.
We can try something and see if that made us vomit and then not try it again.
Mm-hmm.
But like when something is presented to us, if you're using your senses, then things that you see you perceive as true, right? That thing looks red, it must be red. And it's hard for our brain when that like is an illusion to parse it out as such, because it's
Right.
hard for us to go through and trigger that mechanism that falsifies it. So I don't know. Color me skeptical as to whether we're going to be better at this or the AI is going to be better than that, right? Because
Yeah.
we could put some of these bias reduction mechanisms into the AI, and it may eventually become less gullible
Yeah.
than some of
No,
us.
that's true. So, anyways, this is all just like, I mean, I have learned so much and had so much fun moving from single core to multi-agent expert agent.
What's the learning curve of the Lang graph Lang chain family? Like, what would you, if a listener wants to explore that, is that fairly straightforward? Where would you point them to?
Do you want the right answer or do you want the real answer? Because
No, just
I let Claude Code manage it.
why don't you give us any answer and then we'll see if we can figure out if you're bullshitting us or not.
Okay, well, the right answer is that I spent several days reading through the documentation. And once I was done with the documentation, I was able to sit down and spend a few days working through example problems. Once I had the example problems in hand, I was then able to spend a few days building simple solutions to the problem that I had. And then after a couple weeks, I was finally able to fully utilize LangGraph such that I could build this multi-agent system.
And we all know you started yesterday. So now for the
in
other
in
answer.
in actual fact, I have a lot of foreknowledge about how Langsmith and Langgraph works, and that is very important for this. But when it came to actually writing the code, I just let the robot do it. And it actually did not do it perfectly. Like there were some things I had to iron out. And one of the primary issues is that it couldn't remember which freaking version of Langgraph I was working with.
That's fairly basic. So I was
Yeah,
looking to start this a few days ago, and one of the things I did is I watched a couple of videos just to get the overview
right,
of what is happening here. But then I was imagining if I have to critique the code that the AI is going to write,
right.
I should have some mental model of what the heck is going on underneath the covers.
Mhm.
It doesn't need to be like extensive, but
Yeah.
I was going to work with the AI and saying, okay, like give me the overview of how these tools work. Like what is the major interfaces, the big box architecture you have over here. So when I actually dig in and it says, no, we should do this, I'm like, no, 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 no,
Yeah.
that doesn't seem consistent with.
Our workflows are very different at this point. I am going back to suspicion. I tend to let the robot do the majority of the coding, and then I focus on like QA and validation at the end. Like, does this really work the way that it was supposed to? And if it doesn't, then I start digging in. You definitely have a more bottom up approach, and it's hard to say which one's better. I'll be honest. I mean, sometimes,
I think we all know that one, Michael.
yeah, and it's hard for you when I'm right constantly. I know,
Yeah, that is true.
but anyway,
No, I am. So,
yeah,
if joking aside, like I continue to experiment with this, and one of the things that I find is that I was actually doing this morning, and the dang thing couldn't get it around its head of what I was trying to do. So eventually, be like, okay, blow up,
yeah,
stop. Like I went and looked at the files, figured out exactly what was happening. It's like, okay, dude, you're doing this, this, and
hmm
this. I actually want this, this, and this, and then it went and cleaned it up.
yes,
But it was a fairly straightforward problem. It's like I can only have one of these things, and if the user somehow ends up with two, then you got to get it down to one. And I want this checked everywhere, and if that happens, take them to this page.
yeah,
And then everywhere the query's wrong, it's just pulling up the first one. It's like, no, you
hmm
can't pull just the first one because there could be more than one. So if you're pulling that one, so it was kind of interesting to me. Like, I don't think I keep getting stuck, right? If I let
hmm
it run loose by itself, I keep getting to a point where it's just unable to figure it out. It's not wasting time and tokens just going through and through
yeah.
with it.
No, and I do see that. Like I do see that a lot. Where and listen, I am looking through the code. Like this is not normally a yeah, just go YOLO and then I need you to and then I YOLO again. What I have found is more valuable though is like truly understanding the concepts, truly understanding the things I'm working with and applying that to the entire part of the process because the robot doesn't know. It just doesn't.
Yeah, yeah. If you have like good interfaces
Yeah.
and you understand them, like you can let it do the thing inside, and
Yeah.
then you can let your tests run loose.
Yeah.
And like I don't know, examples like HTML code, like I don't really need to get in the weeds because I can like kind of eyeball it, and then I can look at what it looks in the browser, and then I'm good. If your div width is correct or not.
Yeah.
But there's other things where like, okay, why are you passing these three things in this API? That one doesn't make sense. Like semantically, that does not make sense why you're
Mhm.
passing this in here. Go clean it up. And it's like, yes, you're absolutely correct.
I had one, and I know we're getting close to like having to shut this down, but I had one thing happen recently that was like, it was really interesting. So I put a picture of a UI in to Claude Code. I said, I want you to build this. And it went and built it. And I had to ask it to make some adjustments and whatnot. But eventually I ended up with this UI that just looked great. The designer that I was working with put it together and it was awesome. And then I started to notice weird things. And come to find out, the robot had split the state for one particular thing. And so there were three components, each of which were managing their own state about the same thing. And I had to eventually tell the robot, I was like, no, no, there should not be three people managing their own state about this. You need to have a single state management for this. And that's the kind of thing that I have to be careful of with these things because they are very good at compartmentalizing and they will index for too much compartmentalization.
Well, and I think that's where you might have the multi-agent version working here, which is like there's a thing that looks about dry, there's another thing that looks about right interfaces, a thing that looks about this, and each one may be good at its own thing,
Hmm.
and they can review
Yeah.
it. But my sense is it's going to be a while till we can codify these things and practice them and figure out which one's working, which one doesn't. Like I
Yeah.
think there is no way I'm letting a set of multi agents go work for something for an hour and come back with a feature built in code. It's like
God, that'd be so expensive.
it'd be expensive, and I don't think I could evaluate the result,
Yeah.
and it'd probably be wrong.
Yeah. Maybe.
But
So,
3 years from now, I'm bullish.
yeah. Yeah. Well, we're getting closer. But yeah, speaking of, did you hear that Claude Code, they changed all their limits? Yeah.
I read about that.
Yeah. Boy, I saw that one coming. That was interesting. So, anyways, but
I use the API straight up, and it's like okay, $40 every few
all
days.
right.
Pop,
All
pop,
right.
pop.
Yeah. No, dude, I
Yeah.
hammer Opus. Opus is tired.
Oh man,
All right. I'm sorry.
poor Opus.
Poor Opus. All right.
You're probably that little spike at the right
Right.
end of their diagram. It's like that Rollins guy.
Yes. All right.
All
Humans
right,
of...
QA for next time.
Say again.
QA for next time.
QA for next time. Well, there may be an episode between this and QA. We'll see. But yeah, really good.
Next.
All right. Humans of Earth, thank you for coming along and will I snap that. My name is Michael Rollins, and as always, I'm joined by my co-host Thanos, he of the Snapdom. We hope that you have a lovely, enjoyable week as you count down the days for when the robot takes your job. I bid you adieu.